Okay, so I just got this rubber duck and now I'm continuing my CSES problem sheet, but I'm now explaining to both you and the duck now. Um, for this question today, we have traffic lights. There's a street of length x whose positions are numbered 0 to x. Initially, there are no traffic lights, but in sets of traffic lights are added to the street, one after another. Your task is to calculate the length of the longest passage without traffic lights after each addition. So we have two inputs, X and N, which are the length of the street and the number of sets of traffic lights. Then afterwards, it's just a line of each position of the traffic lights. Okay, so how we're gonna approach this question is that if we were to just um remember, have a like kind of like in a list, remember which ones have this, we would have to iterate through the list every time, which would definitely mean TLE. It's gonna be exceeding the time limit for sure. So something we have to do for this question is kind of store things in a set and then just update the set every time so that we get what we need. So I'll kind of walk you through the code while explaining the logic. So essentially, we would have something known as a lights, which is a set, and we would have gaps, which is a multi-set, so that it allows basically it says lights are distinct, so that's why we can use a set, whereas the gaps could overlap, so that's why we use a multi-set. And then for multi-set specifically, I'm going to talk about the logic. So for set, the lights just basically stores, okay, which lights have I added to this? In the beginning, we're just going to start with the two boundaries, 0 and x. And then as we add each light, we just add it to the set of lights. And then what we do is every time we want to find the most closest left and the closest right to that light. So that's only going to interfere with that interval, right? That's the only interval that needs to be updated. Since when we add it, the closest left and right is that interval that's going to be split apart into two. So then we would just delete the previous, what is it called? Condition that we have that gap, and then we just update that gap to be two gaps instead of whatever length we need it to be. Okay, let's walk through the code. So in the front, I did IOStream, include set, pretty standardized. And then next, in my main loop, I first make the input slightly faster with iOS base sync with Studio and cin.tai. Then, as the problem states, I input my X and N. Um, and then I set up my set and multi-set to be called lights and gaps. And then what I do is I first initialize the values. So inside my lat lights, I initialize the two boundary cases of 0 and x to be in the thing. And for my gaps, I know that the initial length of the gap is longest gap is just one gap, which is of length x. Then I go into my for loop of each time adding one light to the thing, right? So then for in I equal to 0 all the way to n, I increment my I. Um, I first have my P, which is basically that light position, and then I input the P. And then I set up my iterator, the right, closest right and closest left. And then I just do lights dot upper bound P. So this kind of because inside a set, it's already ordered by, we can just use the iterator, we can just find dot upper bound, which will find the closest one that's slightly above. So that's exactly what we need for iterator right. And iterator left would just be the whatever's on the right, we just move shift one spot over. Okay. And the next what we have is we want to get the values, right? The iterator is only a pointer of that. We kind of need to reference the exact values of that. So we just define our in left and right to be actually getting the value for with the star. And now what we do is we want to update our set to our gaps to be representative of splitting it into two parts. So we first use dot erase gaps dot find right minus left. So we delete that interval from the gaps because we're splitting into two. And it's important here because we're using erase to have that dot find. So we're referencing one value rather than all of the values. So we only delete one copy of it. And then what we do is insert back the two smaller intervals. So P minus left and right minus P. Pretty straightforward. And then the lights, we have to insert that position into our lights. And then in at the end of each loop, we want to print out the maximum, right? Maximum gaps. So then, because a multi-set is already ordered, then obviously the max is going to be at the end. So what we can do is we can just do gaps dot r reverse begin. So r begin. So that gets the max. And then the end part, like I equal n minus one, question mark, this or this. This is just a formatting thing. So then it just basically either does a space or a no space. It's just a matter of fact of what it is. It's just formatting. And then in the end, I just return zero, end of program. I think the major part of this problem is just realizing that you can't kind of just store the expect to store in the list and then figure it out every time. The only thing you're really doing is storing the gaps and the light and then making sure that the gaps is updated. Only the interval that is affected gets updated. That's the major takeaway from this, so that it's just like two steps rather than like I don't know how many steps you have to go through the whole entire list. Okay, cool. That's enough here.